Hello, everyone.
Hello.
Hello, Paul.
Yeah. Hi. Yeah, Jerome.
Hi. So you can hear me well? It's okay?
Yeah.
Okay, perfect. Looks like my video does not work. I'm sorry. I don't know why it is black when I put video. But anyway, it's not a big deal. If the sound is okay, that's a...
Yeah. The sound
That's
is
what we
good.
need.
So
Hi, Jeff. And just, Paul, before we start, I think there is one missing presentation on Data Tracker. I think you upload twice the presentation on the I2NSF framework for security management. No, sorry, the integrated security service system for 5G network using I2NSF, but there is not the presentation about the young data model for I2NSF. So I think there is just one presentation missing, or you upload it twice the same. Can you still hear me?
yes, we can see. Yeah, Jerome.
Yeah. Okay. Yeah, if you can just quickly check for the missing presentation. We can wait a few minutes to see if more people join. So in the meantime, you can check this presentation. Maybe there is a new one now. Let me check. Okay, now I got it. I just received on Data Tracker. Just add this one to the meeting.
Hello, Jefferson.
Hello, Paul.
Yeah. So are you in Brazil?
Yeah, in Brazil.
Okay, I see. So what time is it? It is a very early morning, right?
Yeah, it's 5 o'clock in
5
4
a.m.
in the morning.
Okay. So thank you for your organizing and attending early in the morning.
No, not a problem.
Okay, I think we're okay now. So I propose we start. Hello everyone, and good morning, good afternoon, depending on where you are, and also best wishes for this new year. So I'm Jérôme François. I'm the co-chair of the Network Management Research Group, and Jefferson Nobre is also with us today as also co-chair of the Network Management Research Group. So, the first slide, as usual, is just to remind our important things, in particular regarding the noteware on the intellectual properties that the IETF laws, the IETF intellectual property rights IPR, so disclosure rules. And here you have, please take time to read this slide and to go to the referred document. The main information that you have to know is that if what you will disclose during the meeting, if it's covered by patent or patent application, you should have basically tell us in a timely manner that this is the case. So of course, yes, you have more information. I will let a few seconds more to let you read this. So next is about audio video recording. So this is an online meeting. So as you know, IETF routinely makes recordings of online and in-person meetings that includes audio, video, and photographs, and publishes those recordings online. So during the online meeting today, it means that if you turn on your camera and or your microphone, this means that you consent to appear in such recordings. So it's not written here, but that is an online meeting, and just mute yourself when you're not speaking, just for making the meeting more easier. So privacy and code of conduct. So again, here we just remind you with the public recording, but we also point here different links and documents regarding the privacy policy. And although that as a participant or attendee, you are able to work respectfully with other participants, and please contact the Ombuds team if you have question or concern about this. You can see here the two RFC, also related to the code of conduct and anti-harassment procedures, and this also apply to our IETF. And you have a complementary document for IETF that is also mentioned here, that is RFC 9775. So NMRG is a research group, Network Management Research Group, so it's part of the IETF. So IETF, that means Internet Research Task Force, it focuses on longer-term research issues related to the Internet, while the parallel organizations, the IETF, focuses on shorter-term issues of engineering and standard making. So IETF conducts research. It's not a standard development of organization. So while the IETF can publish informational or experimental documents in the RFC series, its primary goal is to promote development of research collaboration and teamwork in exploring research issues related to Internet protocols, application, architecture, and technology. And you can look at, as I mentioned, RFC for having more information. Here's a link for today. Please, yeah, you can see that if you look for all the material of the meetings, they are available online on Data Tracker, and there will be also notes that will be used then for the minutes that we will use these notes to make the minute after the meeting. So as announced on the mailing list, this meeting is really focused on two topics, I2NSF and I2ICF. So the meeting is structured in two parts, and we have to really thank you, Paul, for this agenda and for this to have collected the different topics and slides. The idea is to let also NMRG participant to know better about I2NSF and I2ICF roadmaps and works, to see what can be the role of NMRG in these topics, what can be interaction with NMRG and so on. So we'll have some more sessions, one about I2NSF, one about I2ICF, and then a more open discussion globally on these topics in NMRG. That's all from me. I don't know, Jefferson, if you want to add something.
No, Jérôme, I'm good.
Okay, perfect. So what I propose that we start. So Paul, I will just give you, I will share for you the slide and then give you the floor to present.
Okay. So yeah, I will share my slide. Okay.
I can share and give you the control if you want.
Okay, sure. Yeah, I can. Could you give me control to me to share the screen?
Yeah.
Or
Yeah.
okay, I can. Okay. So
Should be.
okay. Okay. Control. Thank you. So hi everyone. This is John Porjong. I'm working for SKKU in Korea. Today I want to share status of I2 NSF and also the next step as a roadmap for I2 NSF. And basically, you can see this figure shows a cloud-based security system using I2 NSF. So basically, left-hand side, we have a smart building, smart factory, etc. So we, for example, could you configure smart buildings and networks such that employees cannot access social networking service website during work hours? So using I2NSF framework interface, we can smoothly providing this security service. The status of I2NSF, we concluded this work, I think the last year, 2025, March. So we want to complete the set of I2 NSF. We finishing like some missing pieces. So I will explain later. So basically, I2 NSF aimed at making a standard framework and its interfaces for cloud and edge-based security services. Basically, I2 NSF working group standardized the young data models, including network security function, NSF capability, and then we have four interfaces like isolation interface, consumer-facing interface, NSF-facing interface, and monitoring interface. And also, we have extended the use case document called applicability of I2 NSF, considering software-defined networking, network functions, virtualization, and service function training. So this slide shows I2 NSF document status. So the first one is applicability of I2 NSF. Remaining the five ones are the young data model, including network security function capability and I2 NSF interfaces. So you can see all sitting RFC EDQ, the authorization. Currently, RFC editor sent a cluster of the review documents to me. So I am working on resolving the editorial the issues to finish those 6 I2 NSF documents. Hopefully, I can finish this February. So the motivation of this meeting, we want to discuss augmentation of I2 NSF because NMRG standardized internet-based networking with RFC 9315. This is internet-based networking, the concept and definition. So we want to make I2 NSF alignment with IBM concept. The first document is how to augment existing I2 NSF framework for security management automation. In order to that, we need to analytics interface young data model because this interface will be used to make policy reconfiguration and deliver feedback message. So today, the Patrick, he is the first author. He will present this document. And also, we have a use case document for integrated security service for 5G networks. Not only 5G, but also 6G network can be accommodate I2NSF for edge-based security. Excuse me. The roadmaps is as follows. So we want to officially present these three draft in NMRG session, and then we need to decide whether to work on NMRG for I2NSF. I believe that this interim meeting is a very useful bridge to consider. We adopt I2NSF the work for NMRG. Once the research group NMRG agreed on the working on I2NSF extension, so we can adopt and then we can using the several revision procedure. So and then I would like last call as informational document RFC, because the RG the objective Jerome mentioned, this is not standardization, but I believe three drafts will be useful for apply I2NSF Yang model to real world. Okay, that's all. Thank you. Any questions or comment? So after that, I will explain other three documents one at a time, including me and other authors. Yeah.
Thank you, Paul. Is there any question for this first presentation? Okay, so what I propose is that we move to the next one because it was one introduction.
Okay,
so
sure. Okay, great.
More content in the next one.
Next one is security management automation slide. Yeah,
I will change the slide. Okay. Let me stop sharing. We stop the slide. Sorry. I think I have to take back the slide control. Yeah, stop slide, share slide again. Yeah, this one, Paul, right?
Yeah, exactly. Yeah, thank you.
And it gives you control in, and then you can go.
Okay, let me start. So this is the first draft for I2NSF extension. So this draft explain the extension of I2NSF for IBM sports. So this figure we showed just before, okay? And then this figure shows the closed loop security controller. So I2NSF, you can see in the middle we have a controller. It is called the security controller. And left-hand side, we have I2NSF user. This user is security administrator. So this user gives a high-level intent using consumer-based interface data model. And then security controller translates into that high-level policy or high-level intent into low-level security configuration. So appropriate NSF line side, we select firewall, and this one is the web filter or DPI, deep packet inspection, something like that. And then so appropriate NSFs are configured with translated low-level configuration. After that, periodically or on event, so monitoring interface collects monitoring data from NSF. So that data will be delivered to analyzer. So analyzer performs analysis using AI or machine learning algorithms, and then it can decide certain new security vulnerability or attack is detected. It generates a new policy. It is called policy recompilation. The other one is existing NSF, some hardware network bandwidth is not good enough. We need to scale up. So in that case, analyzers generate feedback message to take action on those the hardware, some resource issues. And also it can generate some user report. So user also can get current situation. So you can see this figure shows intent translation and closed loop security control. Okay, so this one called intent enforcement and intent assurance. So those are belong to RFC 9315. Okay. So we want to support those two main feature intent the enforcement using security policy translation. I explained the translation of high-level security policy into low-level policy. And second one is a closed loop control. So closed loop control case, NSF, network security function, delivers each monitoring data to analyzer. Analyzer performs machine learning or AI analysis. And then it can generate policy reconfiguration or feedback message through I2NSF analytic interface. So in order to support this new feature, we need a new component. It is called the I2NSF analyzer. The second one is I2NSF analytics interface. Those component and the interface are not belonging to existing I2NSF framework. So we needed to extend. The second one is this draft I mentioned the security audit system. So left-hand side is I2NSF framework component, I2NSF user, security controller, and the network security function NSF. And also right-hand side, okay, we have a new component, security audit system. Basically, we are using a remote attestation interface. We can gather activities of the I2NSF components to detect insider attack and supply chain attack. So this component also can be included for I2NSF. So for our main objectives, the part one is to check the existence of a security policy, management system, and its procedure. Second one is to identify and understand the existing vulnerabilities and risk of either an insider attack or a supply chain attack. Third one is to review existing security controls on operational and other administrative issues. Lastly, to provide the recommendations and the collective actions to security controller for further security improvement. So next step, I believe this draft is a base document to augment the existing I2NSF framework for security management automation, because this draft is can conforms to intent-based networking, IBM in RFC 9315. So that's why I propose this document can be considered for our NMRG. Okay, that's all. Any questions or comments?
So yes, I have one question.
Mm.
So thank you, Paul, for the presentation. Okay, it's for me, it's good that you put the different problems and what you want to achieve. I was wondering because you mentioned a lot of objectives, and I was wondering if you already some prototypes, some tests, where in this type of slide where you have two what you want to achieve, but I'm not sure about what has been already realized. If so, can you just let us know if you already have some experimental work on implementation working on that?
Yeah. The question is implementation. This work.
Yeah, exactly.
Yeah. So you can see the reference two case. This is IEEE Communication Magazine's paper. So Patrick, so he and I, we work for this one several IETF hackathon project. So we implemented a basic I2NSF framework, but also we also implemented our IBM concept like closed loop security control. So we also POC, okay, program concept using open source based implementation and testing. Also, we published the paper. Yeah, that's all. Yeah.
Okay.
Also, yeah, the source code is available in GitHub. Yeah.
Thank you, Paul. I think yes, would be because I know that you want to maybe present again in NMRG. I think it would be good that you show some let's say kind of evaluation or type of demo in the presentation. And what would be interesting if you take, for example, this slides, one of the last slides where you have all the objectives. I don't remember which is the number. Maybe it was slide 6 or 7.
6 or 7?
Okay. Yes, 7. Sorry, it's slide 7.
7.
Yeah. So here you have the form and objective of the audit system, and it would be good to highlight what are the, let's say, scientific lock to be addressed for the different objective. Here we have the objectives, but what is hard to do here? I'm not telling for today, but just for maybe for another presentation to also emphasize the research part of your work.
Yeah. So actually, this security audit system case we didn't implement yet. Our draft just to show our design for security audit system. I think if NMRG think this one is valuable, definitely we can design and implement. But currently, just the design level, not implemented. Yeah.
Okay. Thank you, Paul. I don't know if there is other question. Okay, so let's move to the next presentation. So we'll change the slide. And okay, let me just I have just to reload the slide. I think it was the last presentation. I have to manage slides. Okay. Sorry, I have just an issue. Those slides that I just approved are not yet in the queue. In the interface. I have to check where they are. Otherwise, I will just upload now again. I think they are at the end, actually. Okay. I think it's this one. So it's
Yeah. Can you hear my voice?
yes, perfect. I'll just give you the control and
Okay. Okay, thank you for the opportunity to present our draft of the analytics interface, which is the extension of I2NSF framework itself. Right. So I'm sure that we have seen these slides where we show you about the I2NSF framework itself. And what basically we have here is an extension of that I2NSF framework. Here we will basically in this draft we will talk about the young data models of this analytics interface, where this analytics interface is basically a result of analyzers that they're using, probably like an AI-powered system, so that we're able to find a solution for the security controller or even for the users. Okay. So the motivation itself on why we need this analytic interface is obviously because of the networks itself are not stable, and they can change very quickly in different circumstances. Whether there's an attack, whether there's a hacker, or even unfortunate actions that happen, and we need to be able to kind of mitigate or try to change our policy based on the certain events that actually happens. Right? This is why it is very important where we have an actual analyzers that able to monitor and they're able to analyze this kind of activities. So if we find some sort of events or performance issue within our NSFs, right, we can create it. We can create a new kind of closed loop security control in here, where we can enhance the network security through the analysis of this monitoring data. This is why we need to have this NSF analytics interface, right? By having this NSF analyzers and also this analytics interface, where we provide to the IETF framework, we basically can support an automatic adaptation to the current network condition. So this is the initial draft itself on the young data models. This is a high-level part of the young data models, where the analytics interface is basically provided into two different roles. The first one is a policy reconfigurations, and the second one is the feedback informations. Now, for both of this in the young data model itself, we will have the NSF name, where the name or the IP address of the NSF will be used for identifying which part of the NSF that has a problem. And then we have the problems itself. This is basically about the issue inside that NSF that will require to be handled. And the lastly is the solutions, where this will provide with the possible solutions for the problem itself. So this is the high level itself, where we can take a look more on the policy configurations. Now in the policy configurations, we're basically, first thing first, we have a policy created by the security controller, right? And from that policy that's given to the NSFs, for example, maybe you have a DDoS mitigator, maybe you have an antivirus or any other NSFs in there. Any kind of policy that has been given, and each of those NSF will be monitored by the analyzers. So the NSF will send some monitoring data to the analyzer, where the analyzer will perform some sort of calculation, what kind of things we can improve. And in here, the analytics interface will be used, where the analyzer will provide the suggestion to the security controller. So the security controller will be able to adapt and create or reconfigure the policy itself so that the NSF can perform better. And another type is the feedback informations. And the feedback information is quite similar. But the thing, the difference is that some of the solutions may require the users to be actively involved. So instead of just being handled by the security controller, in this case, we want the I2NSF users to be involved in trying to mitigate the issues. In here, usually this feedback information will be like, for example, over usage, like the memory usage has been fully used, so maybe we need to deploy another different NSF, and usually these kind of things will be handled by the I2NSF users. And basically, with this analytics interface documents, we are able to provide further information on how we can extend the I2NSF and what kind of young data models is necessary so that we are able to create the security management automation with the closed loop security control. And this young data model itself is actually based already on the existing I2NSF young data models. We're using the NSF facing and also the monitoring interfaces. They are basically combined, and we are able to provide a new young data models. And lastly, this is the question. Basically, is actually NMRG is the right place for this documentation of this I2NSF work? Yeah, that is all for the analytics interface. Thank you very much for this opportunity. Is there any questions, perhaps?
Any question? Okay, so I will just comment and ask questions. So maybe first on your last point here is, if it's standardization, as you may know, NMRG is not the right place because we are not doing standard here. It's a more research group, so it's different. So we, as I said in the introductions, we are not making standard, but more it should be more from research perspective. So in regards to what you presented, I think for NMRG, what could be interesting is to, for example, understand the different algorithms that you use in your closed loop to identify the security issues, to make the right reporting level, and rather than only the interfaces between the different components, which maybe it's more related, as you say, to standardization and to young data model as well. So yeah, I think for research perspective, it can be interesting if you are able to highlight what's the difference between what you propose and also, I would say, closed loops that you already see. I've seen in security framework. As you probably know, closed loop security control has been already applied, so it would be important to highlight what is basically new here in terms of objectives, in terms of realization, in terms of algorithm. And if you go more for standardization, you need to look more at the IETF working groups. So either you can go to and more for network management, or you can also look at the security working groups. So it's more comments and suggestions rather than questions, I would say.
Okay, thank you very much. Yeah, it's very interesting in that point that maybe we need to add more on how the research perspective, right, instead of just the standard of young data models in the documents. Yeah, thank you very much.
You're welcome. Other comment, question? Okay, so let's move to next presentation. Just take back the control. Thank you, Patrick. And let me share the next slide, which is about the integrated security system. And Joseph, I think it's your. So Joseph, you have to. Yes.
Hello. Yes.
Perfect. Give you the control, and you can. I hope this is the last one because I received two presentations in Data Tracker at the same time. So I was not sure this is the last one. I hope so. I took in the order I received it, but it was exactly the same time. I mean, what displayed at the same timestamp. So I suppose you upload slides very the same minutes.
So can I start?
Yes.
Okay. Yeah. Thank you and good. Hello. So, I'll present our work on integrated security system for 5G networks with I2NSF. And this work focuses on how the I2NSF framework can be effectively integrated into 5G core networks, and especially to support intent-based security management. And this is the 5G core is defined as a service-based architecture. And as you can see in this architecture, each network functions, registers, and subscribes to service provided by other networks using HTTP2 as the standard communication protocol. And our implementation is based on Free5GC, which is an open source 3GPP complement 5G core complete platform. And the main goal of actually the main goal of the I2NSF is to enable centralized and automatic control of security policies across heterogeneous network security functions. It allows high-level policy like intent-based security policies to be translated and delivered to different network security functions, ensuring consistent and vendor independent policy enforcement. And our goal is to use the IE2 NSF security management system in 5G networks. And this work presents on integrated security system for 5G network based on I2NSF. And as you can see inside on the right side, this is our system, the 5G I2NSF security system. And inside the UPF, there's a NSF2 together. And so with a particular focus on integrating the 5G I2NF security system with the 5G core network functions. And actually, why do we integrate I2NSF into 5 networks? And especially the 5 networks involve massive connectivity like the edge computing and frequent UE mobility. But however, the traditional I2NSF relies on centralized cloud architectures, which introduce latency due to traffic detouring. So this is problematic for latency sensitive edge environments and UE handovers. So therefore, we propose an integrated architecture that embeds I2NSF components into 5G service architectures. So you can see detail on the draft. And this is the I2NSF cloud approach for 5G cloud approach, like the original I2NSF. So this shows the legacy cloud-based I2NF approach. So in this model, the network security functions are executed in an I2NSF cloud outside the 5G core networks. So as a result, UE traffic must follow the detoured path to reach the security services, so which introduce the long delays and degrades the performance. But as you can see in this figure, you can see the I2NS system is this is edge approach part. So this I2NSF is the all of the I2NS components and network security functions are deployed inside the 5G core networks. So it's closer to the UPF and the data path. So this enables the optimal traffic path from the UE to the security services. And because of this, it can reduce the latency and improving the response or responsiveness. And this is the testbed of our I2NS with the 5G core network. And as you can see in this testbed demonstrates the I2NS-based security system deployed on the 5G core network using free 5GC. As you can see, it starts from the IUF on the right side, giving the high-level policy to SCF. And after it translated and make the network policy, and network policy can be given to the 5G core. And after that policy is given to the 5G core, it makes the NSF inside the UPF. And after setting the after NSF is set inside the UPF, when the UE can go from G node V1 to G node V2, if some NSF is set inside the UPF, it has to be migrated. So it is as you can see, number 5 policy migration part. After policy is migrated, even UE is handed over, the same policy can be given to this UE. So, and after that, we have to check this migration is working well. So in the number 7, this monitoring report can be given to the SDAF, and this report can be reused in the can be stored in this DB, and it can be reused when we make the high-level policy again and try to add new policy inside the 5G core networks. This is the testbed of I2NS with the 5G core network. And this is detailed explanation about what I told just now. And our next step is actually this draft presents the security management use case for 5G networks, especially focusing on network security functions within UPFs and policy migration during UE handovers. And we would like to discuss whether this work can be developed as an NMRG draft to demonstrate the particular practical I2NS based use case. And this is draft. This is reference, and this is all. Yeah, thank you very much.
Thank you, Joseph. Is there any question?
Yes.
Okay, I have one question. So as far as I understand, so you implemented your solution on a testbed, and one of your objective, I think, was to reduce the latency in one of the right. So do you have already some results on this? Did you do some tests on your testbed?
I explained about the framework of our testbed, but it's still going on making in the progress of making the testbed now. So I think within this year, I think we make the result about the latency check using the NSF inside the 5G core network.
Okay. Okay, thank you for clarification.
Yeah, thank you very much. Yeah.
Okay, I think there is no other question, so let's move on. Thank you, Joseph. And so let's move to the next presentation. I think next is so now we are going to the I2ICF topic.
Yes, the I2ICF. Yes.
So let me share the slide. Where is the roadmap? think it's because again I just uploaded the slide at the end, so you have maybe to check again and the data tracker and reload here. One map interface. Okay. Yes.
Okay, yeah, great.
Yeah.
Okay,
Thank
let
you.
me start. Okay, well,
Yeah.
thank you, Jerome. So basically, so this second work is the I2 ISAF. This one is more likely related to AI agent. So I will explain. Also, Kehan and also Chris, they also collaborate for I2 ISAF. They can also address their opinion after my presentation. So one typical example is on-device AI. You can see the smart factory scenario. On-device AI can detect fire, also gas, also leakage, also electricity, some burst, something. So those are can detected by various the IoT devices, and then using a AI agent technology, also physical AI, they can handle automatically. So those also it can report to a current situation to a user using a smartphone alarm, something like that. Our goal is how to make the interface in network computing functions for this kind of scenario. The other some aspect is you can see nowadays many robot, so physical AI or AI agent, cyber physical systems case. You can see left hand side, the upper side, some person injured, and then collaboration among IoT devices. They can detect, also take action this patient to deliver to some appropriate some place like a hospital or some ambulance or something like that. Also, the left-hand side bottom case, fire occurred. So the drone and the camera, infrared camera, also robot, they can also detect this fire occurrence and then take action such as extinguishing fire autonomously. Also, right hand side we have GPT or large language model based interaction between some persons and also the AI agent. So the steps of I2 ISAF case, I2 ISAF aims at making a standard framework and its interfaces for service functions like AI agent in Internet of Things environment. Such service functions reside in edge computing devices or IoT devices. The I2 ICF wants to standardize interface young data model, including in-network computing function capability and interfaces like I2 ISF. So the motivation is I2 ISF conforms to internet-based networking IBM. So this the following document problem statement will explain the problem space for I2 ISAF. And the second document, Yosef will present framework for I2 ISAF. And the third document, Byungman Robert, he will explain the one useful use case for cooperative intelligent transportation systems using I2ISF. And also, finally, Mose will explain intent translation framework for IoT domains. So roadmap case also, we would like to suggest our I2ISF, the cluster of this draft, the NMRG. So NMRG can adopt this work, whether this work is belong to NMRG, and then we want to revise those draft, and that we can last call for information or RFCs. Okay, that's all. Any questions or comment?
Okay.
Maybe Jerome, yeah, if you have question, otherwise let me proceed with the next slide
Yeah,
presentation.
it was my suggestion, because next slide we'll add more details.
Right, yeah.
Just this is that statement.
Okay. Thank you for controlling for this slide. Okay. So Ivan, Shen, Chris, and Kehan Yaho, they are collaborated for this. Okay, I2ISF. I think after my presentation, Ivan and Kehan can say their opinion. So I mentioned I2ISF. Okay, so this deals with the in-network computing function in edge computing devices and the moving objects. Okay, so I2ISF will work on standardization of I2ISF, especially young data models. So I believe so service functions such as network functions and application functions, those can construct the AI agent. Okay. So we have 4 presentation today, including first. The scope of I2ISF case, we want to make a document the description of capability and the restoration interface for intent-based service provisioning for the AI agents. For example, for a given intent, the translator can translate intent into policies executable in network computing functions in target network. For intent assurance, a closed loop intent control can make sure the I2ISF framework operates correctly according to the user's intent. I mentioned just before the intent based ICF, we can support the agentic AI because so to support the agentic AI, we need to configure some edge computing device like programmable network devices like P4 switches, and also the on-device AI devices, including moving object like robots and the software-defined vehicle, etc. And also, one AI agent can be constructed by multiple service function like sensing a function, inference function, and action functions and autonomy function. So those function can construct one AI agent. However, to support real services, multiple AI agents needed to collaborate via agent-to-agent A2A protocol. Okay, this one is standardized by Google. And this figure shows the I2 ICEP framework for ICEP management. So basically, this problem statement, we focus on edge, some cloud configuration. Next one is some moving object side configuration. So let me first. So edge side case, you can see central cloud, right hand side. In the middle, we have edge cloud. And so this one shows one example for SDN case. Okay. So let me, sorry. So you can see the edge cloud case contains VNF, okay, virtual network function consensus case, multiple SDN controller case. They might be not synchronized in terms of the SDN flow table. So in that case, VNF consensus, the monitor among SDN controllers flow tables, and then make sure synchronization among those flow tables in multiple SDN controller. So in that case, some this kind of VNF consensus service intent is delivered to VNF consensus. This one is working with multiple SDN controller. Okay, so they can provide certain edge-based networking services. The second one is mobile object, like the software-defined vehicle, for example. So those are called also on-device AI devices. They can communicate with each other using V2V communications, and also it can interact with the IP roadside unit, and then it can interact with the edge cloud and central cloud services. Okay, so this problem statement consider edge side computation and moving object side computation together. So our idea is motivated by CoinRG, computing in network. So basically, in network computing functions is computing devices virtualized like cloud native the function. So we consider services in Coin. We are providing some new Coin experience like extended reality XR and immersive media like Metaverse. And also we can support other new Coin system like in-network control, time-sensitive application, large volume application, and industrial safety. And also, we can improve existing Coin capability, like content delivery network and the virtual network programming, P4. And also, we can enabling new Coin capability like distributed AI training among distributed endpoints for large-scale problems. Okay, the other thing is edge side network configuration perspectives case, the NFV failure detection. So it monitor the NSF SDN switches and SDN via SDN controller, and then detect certain communication link, and then it can also certain the SDN switches are virtualized, so we can detect. So currently we consider NFV, but we can also consider CNF, cloud native function for SDN switches. This one is we showed just before. Among SDN controller, we can synchronize SDN flow table sharing using VNF consensus network function. Third one is NFV based reliable broadcast. So in the middle, we have a VNF sequencer function is used. This one is provide broadcasted data packets for reliable and in order delivery for video streaming. Okay, based on previous services, we have three observation. One observation is functionalities of each service can decompose into application side function and the network side function. So, and then we can name application function AF and name network function NF. And second observation is management configuration of those functions is functionality must be provided by service coordinate. Third one is there is no framework to specify the life cycle of coin-based services. This figure shows the intent-based system in RFC 9315 for IBM concepts and definitions. So based on this life cycle, so this problem statement also explain the goal and enforcement procedure. The goal is we want to satisfy users' intent, and then we can enforce corresponding service into network or IoT devices. The first step is the intent translation. The intent can be expressed in the natural language. So those intent can be translated into network policy and application policy. So each policy delivered to network and application side. So in order to that, we can have two kinds of translations. One is a network policy, including network and security policy. Application case, application related, like the AI agent related policy is generated. And then each of them is delivered to appropriate the service function. So this document try to standardize the data model for capability and registration interface first, because registration of service function, we can translate intent in the appropriate policy, considering actual solving service functions. And then, so consumer-facing case, this interface is deliver intent into some intent controller in the edge side. And then this controller translate intent into network policy and application policy. And then each policy, network policy and application policy are delivered to appropriate devices. And then data model service function facing case also, this is actual low-level configuration interface. And then analytics and the monitoring are also similar to IETF interfaces. So we have two pages. The first page is we want to make a problem statement and use cases, and then framework, and the core data model for ICF capability and restoration interface. Second page is we can make other basic interfaces like consumer facing interface. So next step is I think NMRG is the right place for this I2 ICF. So in that case, we work on problem statement and use cases for I2SF, considering RPC 9315. Okay, that's all. So Kehan and Chris, do you have any comment for my presentation?
Okay, yeah, thank you for your presentation. Can you hear me?
Yes,
Can
I
you
can
hear
hear
me?
you. Yeah.
Oh, okay, good. So yeah, so currently, as Professor Joe mentioned, that the difference between the current problem statement draft, the I2 ICF, with the previous I2, the previous one, security interface. So the major difference is that the current draft focus on the management, function and management. So one thing is that in the document it mentioned that, so in the slide it mentioned that the agentic to agentic, agent to agent in slide 4. Slide 4. So AI agents here. So AI agent can communicate with each other via this A2A protocol. So currently, maybe we need to detail the actual what kind of existing protocols do we have, or we want to kind of define some new protocol by ourselves. So currently, maybe this part A2A protocol is not that clear. Yeah.
So A2A case, you can see Google is leading agent to agent protocol, maybe you know, right? So like along with the model, okay, context or content protocol MCP, right? So I believe a current problem statement case, I didn't address the AI agent protocol and interaction among agent to agent. However, so the Dr. Byungman will present after framework. His work is also considered A2A because the cooperative ITS is currently his work area. So the agent to agent case, maybe problem statement document case, we can clarify using his draft.
Okay. Yeah. So yeah, thank you. So also for the use case, maybe I can add another use case, like the work we did previously for this the intelligent is related to belongs to the intelligent transportation systems work, like you know, to control the traffic signals, intersection traffic signals, to integrate with navigation services. So maybe this one can be one of the use case based on this problem statement.
Yeah. So my plan is currently problem statement doesn't include the use case, general use cases, but revision case definitely we include ITS, like intersection signal control case, also other A2A related stuff we needed to enhance. And then maybe next NMRG 125 Shenzhen, maybe we can discuss more.
Yeah,
Okay, thank
sure.
you. Yeah.
Thank you. Yeah.
Yeah. So, Ken, do you have any comments or question?
Sorry, can you hear me?
Yes.
Thank you, Paul, for your introduction on the ICF topic. So yes, as one of the co-author, I support this work in especially in moving towards in NMRG. I think, as you mentioned, it falls into the scope of network management. So beyond the I2NSF, which typically specifically focuses on security issues. And secondly, that I think there are many use cases that can enabled or enhanced by the in-network compute functions. I know that the COIN RG, the other research group, has already been closed, but it does not mean that in-network compute functions is useless. But on the other hand, there are many use cases or ongoing research work. It's being undertaken in many SDOs or in the industry. For example, in 3GPP, we're talking about offloading many of the compute functions into terminals or mobile objects, like you mentioned, and also offloaded to like the UPF, one of the core network functions in the mobile network. So I think there is very strong relevance between the offloading between in the network elements as well as the mobile object or terminals. So we need such a kind of framework to orchestrate these different compute functions. This is what I2ICF should do. And as you mentioned, like agentic AI as a future scenario, which is, I think I see a very strong interest in IETF and in open source community like Linux network Foundation network. So we can see that many of the devices will be enable like AI like model capabilities. Then it can be seen as one of the kind of compute function within the device. So they also need the network to coordinate this compute with AI functions, and so how they can collaborate to work, right? So I think this topic is more like a research, more correlated to the research group, like just like NMRG. So that's why I agree what you said, and I think NMRG should consider about this. Thank you. Yeah.
Okay, thank you, Ken. Okay, Jerome, so that's your, yeah.
Yeah, I will comment as well. So regarding the scope and if it fits in NMRG, of course, it's not the decision of chair to decide on that. It's more on the group decision. We'll say so. It's important that you attract support from other member of the group, and as we always suggest, it's important that you clearly highlight the research questions, that you try to separate what will be for standard, what will be for more research in your proposed work, and then the idea is that I think it would be easier for you maybe to also have more feedback from the research group. From my side, not as chair, but more as a researcher and participant of the group, I think if I can give you some feedback, I think it's a bit independent of agentic AI. It's in general here we are talking about distributed computation, and if you want to somehow to propose a roadmap and something in that, it will be good to highlight what is current state of the art and let's say meeting pieces in the current state of the art for this type of, I would say, distributed computation from a research perspective, because we have already protocols before that allows you to distribute computing. in different types of device to orchestrate computation on different types of device. And of course, today we have agentic AI, and just say we have already protocols, but we do not have only protocols. We have also open source implementation of task decomposition engine. We have semantic routers that have been proposed to also route the different tasks to the right tools and to the right agents. So for me, if as a participant, what would be good to understand right the scope of your problem and the novelty of things you want to address is that you make a clear state or review of state of the art and show how this differ from what we have in agentic AI, but not only agentic AI. I would say multi-agent computation, let's say frameworks that have been proposed for years with different, of course, different objectives. So it will be important to understand what will need to be new here for this type of problems.
Okay. Okay, Jerome. Okay, I think your comment is reasonable. So we co-authors try to address what is the research, some issue and value. So in terms of some network management, something. So yeah, definitely, yeah, we are trying to working on it along that point.
Thanks, Paul.
Okay.
Maybe we have to move to the next because otherwise we maybe lack of time for the discussion at the end.
Yeah, right. Yeah, so let's move on. Okay. Yeah.
The next one is framework for the interface. Yes. I'm sorry for the time, but it looks like the slide deck is not in the order and similar to the data tracker, but I think no, it's a good one, right? And yeah, it's for you. I give you the control, and then you can start. Thanks.
Thank you very much. Hello, and I present our draft interface to in-network computing function I2ICF framework. And this draft proposes a framework to manage and configuring the in-network computing functions. And this draft defines a framework for managing and configuring for I2ICF, which are essential for network environments like NFV and SDN. And the main contents of this draft are in-network computing functions, ICFs, and framework components and interface in the I2ICF framework. And it shows an example of the I2ICF framework applied to an edge cloud environment. And in this scenario, we consider in-network computing functions such as people switches, VNF-based consensus functions, and barrier detectors and reliable broadcast mechanisms. And this framework shows how multiple SDN controllers within the same edge cloud can be synchronized using the VNF consensus architectures. And also, this shows another use case focusing on mobile objects, such as on-device AI devices or vehicles. And this framework integrates both wired and wireless network across multiple subnets managed by the central cloud. And the mobile object communicates through the V2V and V2I links, while moving across different edge clouds. And the I2ICF framework enables consistent management of functions, even under mobility and dynamic network conditions. And this slide shows I2ICF framework, especially on the ICF management within the edge cloud, and it is consist of the, as you can see, central cloud and edge cloud, and it can start from the intent can be given from the I2ICF user to the cloud controller, and then that intent can be translated into the high-level policy inside the using the intent translator inside the cloud controller, and that policy can be given to the edge cloud, which is inside the edge cloud part, and inside the edge controller, there's a policy translator, and with that, the high-level policy can be translated into the low-level policy. And as you can see on the right side, there's a edge vendors management system, and all the service functions and information can be registered on the edge controller with the registration interface. And this translated low-level policy can be given to the network security functions, as you can see in the bottom. All of the network functions like the sensing module, localization tracking, VTX module, AI modules, these kind of things. And within using this policy, inside this network security function, configuration can be changed, and the user also want to check if this kind of the applying the policy inside the network security function can be working well. So to monitor it, the edge analyzer can monitor all of the network security function, and each of the network security function can follow the low-level policy. And after this edge analyzer checking the monitor and checking the network security functions, it gives the result to the cloud analyzer, and user can check the all of the network security functions is working well, just following the low-level policy, which was the from the beginning the intent of the user. So this is the all of the closed loop of the working I2 ICF framework. And also we extend the intent-based approach to mobile object too. But the whole system is similar. The different part is the upper part is the central cloud. And also you can think like that this is the edge cloud, and the lower part is the mobile object. So it's the similar like the edge cloud, and the mobile object also require automatic configuration and management. So therefore, intent-based management is applied between this edge cloud and mobile object too. And this enables the centralized control while allowing mobile device to operate autonomously based on the translating intent. And this is the detailed explanation about what I explained on about the figure. You can see the detail about how each component is working. The same, and it's the same. And this is the interface of the I2ICF framework. And you can see the detail how each of the interface is working inside the I2ICF framework. And this is to summarize this document proposed on I2ICF framework as an intent-based system for both mobile objects and edge clouds. And based on this framework, the virtual light functions can be orchestrated efficiently supporting agile agile reconfiguration and flexible updates. So as next step, this draft will be enhanced with several concrete use cases, including like this follows. And our I2ICF group plan to prepare the hackathon or side meeting on next IETF 125. Yeah. Thank you very much.
Thank you for the presentation. And we have questions.
Yes.
So we do not have questions. So I propose that I think it's good that you have here the plan for the hackathon as well. And what I propose that we move maybe to the next presentation, just for the sake of time and to have a global discussion at the end.
Okay. Yes.
Except if there is question, but I don't think there is question now. Not from my side, at least. Okay, so let's move to the next presentation. That is already, I think the first one you mentioned here, Cooperative Intelligent Transportation System. Again, the presenter is young man Robert Han. So I give you the slide control and then you can start.
Okay, hello everyone. I'm Byung-man Han from KP. Today I present recent work on in-network computing interfaces for corporate ITS. Let me briefly explain the motivation behind this draft. In cooperative ITS environments, communication, computation, and control are becoming tightly coupled, and many decisions must be made in real time. However, existing approaches do not clearly describe how in-network computing functions should be orchestrated across these domains. At this time, recent discussion on agent-based and autonomous networking suggests new opportunity for more adaptive and context-aware operation. Based on this draft explores how I2ICF combined with agent AI can support coordination and decision-making in CITS environment. I think many people know recently Google introduced the A2A last year protocol as an approach for interoperability among autonomous agents. This work highlights a broader trend toward agent-based coordination rather than centralized control. When you look at this direction, we felt that a similar concept could be meaningful for CITS environments. In particular, by integrating agent AI into IT shape, it may become possible to support more autonomous and context-aware orchestration in real-time VTX scenarios. While looking into agent-based approach, we also noticed that similar discussions have been actively taking place with the IETF since last year. In particular, topics related to AI agent communication has been discussed across multiple meetings. For example, the MCP model was introduced at I2ICEP 123, and more recently, agent to A2A interactions such as A2A and AMP has been discussed during the last meeting. This made us feel that exploring agent-based coordination with our framework to be more appropriate and sustainable direction. These figures illustrate why intent-based management is required in CITES environment. In real intersections, multiple entities, vehicles, pedestrians, cyclists, and roadside units interact simultaneously. Each participant has different movement intentions, such as going straight, turning left, or turning right. These intersections generate multiple communication patterns. However, current system mainly focus on message level delivery, not on understanding why those messages are exchanged. As traffic density and service complexity increase, it becomes difficult to manage communication behavior using static rules or predefined configurations. Therefore, this scenario motivates an IBM system where high-level intentions, such as safe intersection, crossing, or conflict avoidance, can be interrelated into network communication and control actions dynamically. This is a key motivation behind introducing IBM in CITES environment. And it shows the I2S framework and its major interfaces of the CITES ecosystem. This architecture connects the ITS Center cloud infrastructure, mobile MNOs, and RSUs, SDVs, and vulnerable road users, and through centralized interfaces. However, as we move toward more autonomous and intelligent operation, simple centralized control is no longer sufficient. Therefore, we believe this framework can be further extended by introducing A2A intersections, in particular inspired by recent approaches such as Google's concept, its domain including vehicle, infrastructure, network, and security can be modeled as autonomous agents. These agents can negotiate, cooperate, and coordinate with each other based on shared intents rather than relying solely on static control flows. Following slides includes more detailed explanation of the concepts of components. Additional slides are provided for reference, so I would like to skip it. And then this slide presents example use case of I2IC applied to CITES environment. The key idea is to enable sufficient data processing and streamline traffic management by coordinating multiple domains. In current deployments, traffic and safety information is collected by various CITES centers and government public centers. However, this information often experience high latency when delivered to vehicle and vulnerable road users. By leveraging I2ICF, intents relate to traffic efficiency and safety can be shared across centers, infrastructures, mobile networks, and vehicles. Latency-sensitive information can be delivered through optimized 2x and V2N paths, while less time-critical data can be processed at the central level. This allows the system to dynamically select appropriate communication paths and policies based on service intent, such as real-time traffic control or incident notification. This use case builds on previous scenario with additional security mechanisms such as encryption and key management. On this slide, I would like to briefly show a real-world deployed example. Actually, it was a video, so I could not upload the video, so it's just like a screen I captured, collect from actual real environment. We implemented and where multiple vehicles and also specific communication system was used in this test. The purpose here is not to demonstrate the communication technology itself. Rather, this environment shows the complex multi-vehicle CITS system can be practically constructed and operated in real world. Based on this type of deployment, the proposed intent-based and agent-based approaches can be naturally integrated regardless of the underlying communication systems. To conclude, this work presents an initial framework was use case based on our previous implementation and field experiments. Moving forward, we would like to further extend these results by exploring more advanced intent-based and agent-based approaches. In particular, we are interested in studying how A-to-A intersections can be effectively integrated into CITS and SDV systems. We believe that the topic aligns well with the ongoing discussion in NMRG, and we would welcome collaboration with the IETF community to further develop this direction. Thank you.
Thank you. Do we have questions?
Maybe Jerome. So after the intent translation presented, we can discuss. Okay.
Okay, sure. If there is no, I think Jefferson maybe has a question. So maybe.
No, I can make my question after the next presentation. It's okay.
Okay. So let's move on to the I think last presentation, and then we will open the floor for discussion. And this presenter is Mozi Gu.
Hello.
Hello. Yeah, give you the control, and then you can start.
Okay, thank you. Hello, my name is Mozigu from Sanyuan University, and I'm going to present the intent translator, aka intent translation framework for IoT network. And this is the link to the draft I wrote. You can find out through the link on the presentation. So why do we? I'm gonna start with the presentation with the insight. Why do we need an intent translation in IoT networks? So as networks evolve towards 6G and large-scale IoT, the operating them manually is kind of no longer feasible. It's really difficult and costly. And modern network must handle ultra latency, massive connectivity, and dynamic resources all at once. So intent-based networking was introduced to address this. Instead of configuring networks function by function, operators. So the key idea is that instead of configuring networks function by function, the operator can express what they want, and the system can handle it and achieve the operator's intent. However, this promise breaks down in practice because of the semantic gap between the natural language and some network policy. Human intents are written in natural language, which is ambiguous, sometimes incomplete, and very context dependent, while real network policies must be precise, symbolic, and grounded in knowledge graphs, such as those defined in 3GPP standards. So large language models help with understanding language, but they often fail at symbolic grounding. They can produce policy. Of course, LLM can produce policies that look really sometimes correct synthetically, but yet it violates network constraints or standards. That's what we often call it as a hallucination. So existing solutions fine-tune LLM meets cost or fragile problem, as I mentioned, the hallucination. And another solution is that embedding-based retrieval, often embedding-based retrieval, but it sometimes ignores the internal structure. So our key observation to this is that intent translator is not retrieval problem. It is a reasoning problem. So to translate the intent reliably, we must explicitly align intent components with structured knowledge graph policies under relational constraints for reasoning. So the figure I show is the overall architecture of our intent translation, which is the motivation behind our work. So the process starts from the left. The IBM user provides natural language intent, such as creating intent to improve radio network coverage in the city center. So yeah, then the intent extractor is the first component. It meets the first component intent extractor. It parses the text and identifies the semantically meaningful components. Instead of treating the intent as a single sentence, we explicitly decompose it into a structured slope, such as action, expectations, action, expectation subject, and expectation object. And as you see, is the semantic mapper. When the intent extractor extracts the intent, the semantic mapper, it maps into this kind of the semantic graph, and and through these slots are then mapped into a shared knowledge graph embedding space through the semantic mapper, backed by a domain knowledge graph. So each slot is embedded independently and preserving its semantic role. Next, the intent resolver, the third component, it performs the reasoning over the domain knowledge graph. Here, the intent embeddings are aligned with candidate case triples, enabling the intent-aware reasoning rather than simple text matching. Importantly, this reasoning is the degradation aware, which is the closed loop, which marks the closed loop. If part of the intents are missing or ambiguous, the system leverages the partial case knowledge reasoning and records this feedback signal instead of feedback signal to fulfill the closed loop and the intent assurance. So when it meets the confidence evaluator and evaluated as is reasonable, it goes to the policy composer and it generates the high level the net policy. And this is the overall procedure of the intent translation. So the draft of the intent translation is the framework for translating high-level intents based on natural language into validated structured policy, such as YAML documents that can be executed by a network orchestrator. So it can solve the manual policy translation bottlenecks and enable autonomous and scalable policy enforcement. And most importantly, this bridges gap between natural language intent and machine executable policy. So the key components are mentioned as previously, but I'm gonna go over them more detail. So the key contribution of this draft is probably the intent translation itself, and the semantic mapping, and the intent resolver, which is a reasoning, which stands for reasoning process in knowledge graph. Also, this one is a ASCII code based our ASCII code based of our framework figure. So when IBM user delivers the intent and it in intent translator, it proceeds this kind process each step by step, and then it generates the policy and deliver it to the orchestrator. So I'm not going to go over all details in each component because I mentioned, but I want to highlight the key factor of them. So the intent coordinator is just some kind of gateway that receives the intent and deliver it to the extractor, or receives the policy from the policy transposer and deliver back to the orchestrator. And coordinate is just a simple option of that. And extractor is a LLM based model which extract the key component from the natural language, and it parses to the key element, as I mentioned, the action, source, and destination kind of stuff to build intent vector. The semantic mapper is a pre-trained embedding space. We trained them with the knowledge domain the domain knowledge graph dataset, and so this module, it vectorized the extracted intent to enable the reasoning process, which held in intent resolver. So intent resolver when intent vectors meets the intent resolver, it uses the intent vector as a query vector to retrieve the suitable and most accurate policy, which is stored in the policy knowledge base. And the policy composer is just the template based in 3GPP YAML data model, and I'm going to go over more detail about the core components, semantic mapper and intent resolver. So in semantic mapper, and there, as I mentioned, there's an embedding module and parser which performs the parser vector encoding, and it aggregates them into the intent vector, which and it uses the simple neural network to learn a simple neural network, and is it has the individual slot weight, and is a weighted sum of the intent vector, and it delivers the intent resolver, which has this kind of mechanism. Or intent resolver performs the soft matching for the prior reasoning, and it evaluates the confidence whether the reasoning is reliable or not. And if it's not, it leaves the feedback log, and it goes back to the knowledge base to fulfill the feedback loop in closed loop. And if it's confident enough, it forwards to the policy composer. So as summary, so this document proposes the practical and scalable architecture for intent translation. And through this, natural language intent can be reliably mapped into structured policy for automatic network service configuration. And based on the proposed framework, it enables knowledge-grounded automation in complex service domains such as IoT network and intelligent edge infrastructure. Next next step, I'm gonna work on the draft. I've had several feedbacks and some considerations, such as deployment consideration and human oversight consideration and security consideration. I'm gonna go over them and fulfill to meet this kind of consideration. And also, we are preparing for the next ITF next ITF hackathon and to project to clarify intent translator and use case of agentic AI agents. And that is basically all for my presentation. Thank you.
Thank you for the presentation. I think we do not have so many time for question or comment for this specific presentation. But anyway, I just want to make a comment, and maybe you can then interact offline on the mailing list. Is that you start with IoT consideration, and looks like for me what you propose is something that is not IoT specific in terms of intent translation. The other comment is that it looks very like almost a retrieval augmented generation system like we have in AI today, and so I don't think in terms of architecture is very different. And globally in our group, I think what could be nice, whatever the type of application domain is, IoT, is core network, I don't know, is that there are a lot of people, even in the last IETF, working on intent translation using AI, using this semantic mapping, and so. What we are missing today is data set and benchmarks to train and evaluate the different models. So just a global comment, not only on your presentation.
Okay. So I hope I understood your question. Does you mean why am I narrowed into only IoT network, which could be generated?
Yeah, it's my point. It looks like very generic. And even in the last slide, you see it's more. In the slide before, it was very more generic than IoT specific.
Actually, the reason why I narrowed to the IoT only is because IoT management is kind of more specific, and also I consider the specific use case. Since if I go for the really generic problem, I thought the narrowing down the use case would be really difficult, and also I wanted to fit in the I2ICF framework, which is mostly aims the AI agent, and that is kind of why I targeted the IoT network.
Okay. Thank you. I think we can move to some other discussion, but I think Jefferson, you had a comment before.
Yeah. Can you hear me?
Yes.
Yep.
Yes. Yeah.
No, my question is more about the implementation status of the frameworks, because in the previous presentation there are some information on application and a scenario, but there's no information on the level of the simulation that is performed, or like in what level are you expecting to implement the framework, and in what are you expecting as other implementations to interact with?
Okay. So can I answer, Jefferson? Can you hear me?
Yes, we can hear you. Yeah, please go.
Yeah, I can hear you.
Yeah. We did several hackathon project. So we implemented mainly pre-5G for a 5G network. I2NSF case, we used the pre-5G C, and so also we virtualized user equipment. We tried to work on that emulation, that based one. And I2ISF, So last presentation case also, last hackathon project, we also using robot. So we try to give some robot, like gives some direction moving. In the meanwhile, there is some person detection, and then using a video, recognition using YOLO, the version 8, and then the robot stop, and then people is moving, and then make some safe distance that follow. That is we implemented using robot car. Okay, so we POC also we translate. So we like make a simple edge computing environment, I2 ISF, and then moving object is a robot car like a limo, something like that. Yeah, commercial robot car. Yeah. Yeah, that's right. Yeah.
Okay, thank you. No, because I think that as I'm speaking as a participant, I think it's best to have like the information of the implementation status along with the proposal, so we can see if there is how can I say, we can see in what level the things that you were proposing as frameworks and more like conceptual stuff are aligned with the implementation roadmap, and if it's possible to also to provide to the audience some pointers in order to try to to use the implementations, and or how can other people that is interested can contribute to the implementations. I think this can this can bring more people in order
Okay.
to work along with you and your team.
Okay. So so currently our hackathon project, we also maintaining GitHub, I2 ISF. So we also had several side meeting. So definitely we can maintain a GitHub project, embrace more people. Okay, thank you. Yeah. So okay, Jerome and Jefferson. So maybe this time is the good time we introduced the I2 NSF, I2 ISF work fully. Maybe Jerome and Jefferson, you guys some guide how we contribute I2 NSF, I2 ISF. So we not necessarily make some standardization, but we try to make some good research work for I2 NSF and I2 NSF for NMRG. Yeah.
Yeah, we are running a bit out of time, but I will give you a very short answer, short guidance. So yeah, as I said during the meeting, what is important is that you get support for the group. So I can only encourage you to also try to get in advance before the next IETF to have some discussion on mailing lists, so you can use it as you want. I think it's really important. As I say, make clear difference between what will go to standards, what will go for more research, and what are the research question. I think for me also as participant, I really need to understand what is the let's say the difference with state of the art, and to really understand that. I think there are, to be honest, for participants, I think for some specific points are really good research, probably with some research question. For example, in the last presentation, I think all these things that I taught about benchmarking, to have some models that are learned for doing this intent translation in specific context will be very good, but it's very specific problems. So it needs for me as participant to have this clear view on specific problems. And also, I will also encourage you to also approach other groups, for example, working groups, if it fits more for standards, but also research groups, because if you are talking about, I think IoT, we have, I think, one research group like T2TRG, if I'm not wrong, and maybe also that could be also interesting. It's just a way, to be sure that you will have feedback from people that could be interesting. And also, yes, if the group will provide you feedback. As I said, we are not the decider. We are just a bit running the debate. But we cannot force people to contribute to your topic, and so it's more in your hands to convince people on that. Of course, we can help, give you time. So we discuss with Jefferson. We can give you time to next idea, but in that case, will be shorter time, meaning that also you have to make the kind of aggregated presentation of the work rather than presenting all individual drafts as we have done today. But of course, we'll try to help you as the best as we can. But also, yes, it's as I said, it's good that you have hackathon. If you present some implementation or some result, will be also good. I mean, like research papers. I think this really help to at least attract interest a bit more from the people from the group. But it's just overall guidance. We can discuss more, but I will encourage you to use mailing lists to try to reach people on other groups as well, just to to have more feedback.
Okay, great. So you say we just focus on the research, right? So instead of some actual standardization, right, perspective, what is the research issue in I2NSF and I2ICF, right?
I think you can say that this is more standard, but of course in NMRG we not focus on what you want to standardize because it's not the goal here. But of course you can mention it that there will be also part for standards, but here focus on research.
Okay. Okay, great. I see.
Yes. Yeah. So it's a bit fast, but we have to end the meeting. We're already over time.
Okay.
Thank you a lot, Paul, for helping us to organize this meeting. And maybe I don't know, Jefferson, if you had some concluding words. Sorry.
No. I just want to add up that I know that the time is up for the meeting, but the really question, at least for me, is how people in the research group is interested in how much the people are interested in this work. So probably the best thing to do is to have the conversation on the main list and see what we get from there.
Okay, I see. I got it. Okay, thank you, Jefferson, and thank you, Jerome. Okay.
Yeah. Thank you very much, Paul, and
to
all.
Thank you. Okay, thank you. See you, Shenzhen, in China.
Thank you.
Bye-bye.
Okay, bye-bye.
Thank you. Bye-bye.
Thank you.